Okay, 2 minutes past the hour. So I'd like to welcome everyone to the December ECSS Symposium. Thank you very much for taking the time to join us today, the holiday edition, if you will. So we've got two presenters today, well, three actually, but two topics today like we do for most of the symposia. And our first one is going to be Trevor Cooper from here at the San Diego Supercomputer Center and Fugang Wang from Indiana University. They work together on SDSC's COMET project, and what they're going to talk to us about today is the virtual cluster capabilities of COMET. So this is basically the ability to create an overlay so that you can bring your own software environment into COMET, still have the high performance features of COMET. So kind of a little bit unique mix of cloud and HPC at once. And they're going to kind of build on what they described at the tutorial at Exceed 16 this past summer, and looking forward to hearing from them and also demoing some of the capabilities. So with that, why don't you take it away, Trevor?
Okay. Thanks, Nancy. So first of all, I'll just introduce myself. Nancy already said I'm Trevor Cooper. I'm one of the programmers on the HPC Systems group team here at SDSC. Been involved in developing the virtual cluster capability for COMET and managing the system in general. Fugang is here from Indiana University. He's part of our team. Indiana University folks actually do kind of the front-end user support for COMET Virtual Cluster. And so when a user who is actually a virtual cluster administrator needs help, they'll typically go directly to the IU team, and then if needed, they'll engage us in resolving any issues. So without further ado, let's get into kind of the brief overview that I'll do first, just to kind of bring some people up to speed if they don't already know about our virtual cluster capability, and then dive into some demo and show you some capabilities of our tools, and then get into some questions, and we might do some kind of live demo for people as we get going. So first of all, the thing I wanted to point out most importantly about COMET's virtual clusters is that what we provide isn't the same as say like Jetstream or even other cloud providers. We don't give you kind of an OpenStack-like environment. Our goal is to provide what we call a near bare metal HPC performance and management experience. It's really kind of a testament to our CTO's kind of vision on how we're going to deploy and develop cluster capability on COMET. And so unlike other systems where you'll start up with from an interface and boot a pre-configured image, you actually get basically the closest thing to bare BIOS boot of your nodes and full install capability of whatever software you want to install. Part of the reason that we're doing this is because of some research that was done early on in developing the proposal for COMET from folks who used to be here who aren't now. And the main reason is to provide a capability on COMET that gives you virtually the same performance in virtualized cluster as you would have on the full system through batch. There's a small penalty and overhead running in virtualized mode on our system, but if you look at the graph compared to what you could get on Amazon EC2 at the time of this research, it's much faster and almost as fast as native performance for doing MPI on the IB side in COMET. There's a lot of kind of system characteristics that you can find on the Exceed website about our system, and kind of highlighted here are the pieces of our system that are used or leveraged for the COMET virtualization capability. Basically, virtualized compute nodes run on standard COMET compute nodes and make use of our InfiniBand FDR network for communication between nodes. Typically within a rack, nodes have full bisection bandwidth, and there's 4-to-1 oversubscription across racks. You don't actually get to pick the nodes that you run on in the system, and that's kind of a good thing because we don't reserve the resource specifically for virtualization. We actually share the resource with regular compute jobs, and I'll get into that a bit later. So it's possible that your nodes, when you spin up for an MPI job in your virtual cluster, they might be in different racks, but performance, again, is already a little bit penalized, and you probably aren't going to notice it that much anyway. The other features that we have or use to provide this capability are what we call our hosting nodes. We have about 8 of these nodes with a lot more memory than even our compute nodes have. Not quite as many CPUs kind of provisioned out, kind of build it and they will come model. And this is where your front ends will run either for a gateway or for a front end of a virtual cluster. These are on 24/7 and are done a bit differently than compute nodes, and I'll get into that a bit in a bit. Lastly, we have some NAS systems attached to the machine where we store the images for your front ends and compute nodes. Basically, it's stored in a 50 terabyte raw ZFS system, and we use some features of ZFS to provide access to that storage on the nodes. You know, kind of comparing Comet virtual compute resources to other resources that are out there, you know, a Comet virtual compute node gets all 24 cores on the machine and virtually all of the memory available in the physical machine, as well as up to about 100 gigabyte backed SSD virtual disk local to the node. We've got the FDR InfiniBand for MPI and IP over IB. We've got 10 gigabyte Ethernet shared NAT through the front end for public network access. Basically, running a Comet VC node will burn about 576 SUs per day, and that's just on core hour compute time. On Amazon, the kind of 2 most comparable instances that you'll see are like a C4 XL and a C3 4XL. They have fewer cores, less memory, and either EBS backed or slightly larger SSD backed. If you use those 2 types of instances, you can get what they call advanced networking features, which gives you, you know, 10 gigabits per second flow inside your virtual cluster if you use placement groups to set up your nodes, and about 5 gigabits per second outside the machine. Running one of those instances runs you about $20 a day of real money. So that's kind of the comparison straight across on what you could expect to spend on SUs versus cash for the same, well, not same, but a similar type of resource. I kind of mentioned this a little bit earlier. Again, Comet virtual clusters have 2 types of nodes. They're front-end hosting nodes, which are single-purpose nodes. They're running in KVM on our front-end hosting machines. They're up 24/7, and during the time of your allocation to run virtual clusters on Comet, the front end doesn't actually debit your allocation at all. It just sits there as a resource that you're able to use. The nodes are intended to be kind of modestly provisioned with a few cores and a modest amount of memory. There's the capabilities for us to attach more storage to these nodes, but the standard machine image for these is in the, you know, tens to perhaps 100 gigabytes in size. Compute nodes, the actual physical nodes are dual purpose. The compute nodes themselves are either used for our batch system or they're used to host Comet VMs. And it's a one-to-one mapping. Our virtual compute node runs on a full physical compute node. We don't share the node and we don't give you a slice of the machine. You get a full compute node. And one of the features of our virtual cluster environment is that when you start up these nodes, they're allocated on demand and charged through our batch system to the allocation that you're running under automatically. There's nothing for you to do to make that accounting work. All of the parts in our batch system are used the same way for the jobs that are running in your virtual cluster. Some details about virtual clusters themselves. So Comet virtual clusters are Beowulf style. There's a front end typically in compute nodes. They've got a private cluster management network, and they can have, they don't have to have, but typically would use the IB network as well for MPI traffic between nodes. One of the big things about virtual clusters in Comet is that deployment and management of the cluster is completely up to the virtual cluster admin. We give you bare nodes. You have to install the software stack that you want to use. We think of that as a feature rather than an impediment. We don't require you to install a specific software stack. We don't require you to use Linux or a specific version of Linux, or you could even install a Windows cluster if you wanted to. So just a quick overview of the design. So again, we've got a front-end hosting node, physical compute nodes. virtual cluster will spin up VMs on some of these different nodes. You'll have an Ethernet network and a high-speed ID network. And via your front end, your nodes can all connect to the cloud. So you can ship your data into your cluster through your front end. You can store it on your front end if you have space there. The compute nodes can NAT through the front end and get to outside resources. More than one cluster obviously can exist inside Comet side by side. Again, the front end hosting nodes might have more than one front end, but the compute nodes are dedicated. Typically, you'll use our API to talk to your front end, and this is via what we call a service hosting node. You'll use tools to connect to resources on the hosting node and control your machine. And so this is kind of the overall view of Comet VC, how we see it, and now we go into kind of demo of actual stuff. So let's do that part now. But I guess first what I wanted to mention was we have some resources to kind of point you at. So on the Exceed website, under the documentation for Comet, there's information about virtual clusters in there, kind of talks about our resources and how and you would go about getting an allocation on Comet. Basically, the best way to do this is with a startup allocation request to our system, and you check the box that says, I want to run Comet VC, and you describe what you want to do, and then our team gets in touch with you and figures out what your requirements are and how we can meet them for you. We've got similar information in our Comet user guide, as well as a video talking about kind of the features and kind of how it was used to say do things like support OSG's virtual cluster, where they used our software to help confirm the detection of gravitational waves. Into the details of how you interact, we have a REST API basically that you use to control your system. And you could use the REST API directly and power on, power off nodes, grab console. But we've gone a step further and tried to kind of simplify this for you as well, leveraging work done by Indiana University with their Cloud Mesh tool. It's a kind of a tool that can be used to interact with all different kinds of cloudy-like virtual cluster or cluster type environments. And they've extended that tool to support Comet directly with commands inside the tool. We have documentation online that describes virtual clusters in general, use of them on Comet, and kind of some of the key links here that I'll show you some information from are in this documentation. And some of the terminology that I'll use. I'll try not to go into too much jargon, but things are described in here. This kind of ties into the tutorial that we did at Exceed, where we provided kind of this documentation and layout for how to kind of complete the installation of the Cloud Mesh tool and how to set up a complete virtual cluster. I'll take you through some of this now. It's basically pre-baked for time reasons. We're not going to go through a complete install of the tool or even complete install of clusters, because that takes more time than we have for this demo. So I've got kind of pre-baked systems ready to go to show you some features. One of the things I'll show you, though, is that you don't have to do everything by scratch. We've got a repository on GitHub where we have the tutorial set up, and it's kind of the thing that takes you through there. There are even some scripts in here where you can kind of use them to set up your virtual env to get the Cloud Mesh tool set up on your machine. Either follow along and do the instructions yourself, or go ahead and just start running some of our scripts to get things working for you. Now into live demo mode. So some of the things that we wanted to show you were via the Cloud Mesh API, how you can get access to the node. So one example, or the Cloud Mesh tool, is either a command line tool or a shell tool. In command line mode, you can use the command cm for Cloud Mesh and say Comet and say, for example, LL, which will list all the clusters that you have access to. I'm basically admin on the system, and so I have access to all the clusters that are currently configured inside of Comet, so I can look at all of them. Simplify this a little bit and get down to kind of the things I'm going to show you. I'll show you only one cluster, and In this example here, you'll see that this cluster called VCT01 has a front end, a couple of compute nodes, and the front end is currently on. If I go into shell mode, it's a little bit similar than that. It just kind of jumps out of one level, but you can see you get the same kind of access to your nodes in the shell mode. And there's additional commands where you can get further details about your nodes. And in this kind of information, you can see the specific compute nodes are turned on. Their state is active. You have the MAC address information to use to provision your nodes. Some other details, you can see how many CPUs are in the nodes, how much RAM they have, what the disk size is. You can actually see that these nodes are running in these things we call compute sets under this allocation. This is a test allocation. It's not actually being billed, and that their disks are synced. Another cluster that we have where nodes aren't turned on right now, and I think I'll show you this one because I'll show you powering on a node. You can see on this system, the front end isn't powered and the nodes aren't powered. So we can kind of demonstrate how to power on a front end. Again, these run kind of all the time or kind of on, on your request and don't require or not required to be turned off, but you can power them on and power them off. Again, typically your compute nodes access public network through the front end. So you want to have that on before you power these if they need access to the outside network. Another thing that you can do with Cloud Mesh is you can get console for the node. We use YubiKeys to control authentication to get your API token for access for things like shell, and then we actually used authentication again to be able to pull a console on a machine. And so this is actually a live view of this node booting right now. Provided through tools that we provide, and you can kind of see, I'll just kind of make it go a bit quicker and just have it boot up. This particular machine is a front end that I started installing with OpenHPC cluster fairly recently, so it's not completely configured, but kind of gives you the idea of how to boot a front end and that you basically have direct access into here while you're booting the node. Let's see. So that's booting a front end, and we can kind of go back to that and look at it when it's fully booted. But let's look at another cluster. I think I have this one ready with just not what I want. You'll see that you can actually have more than one of these open at once. This one's already booted. I'll just pull that away. These nodes are booted as well, I think. Trying to remember right now which. We have everything booted. Okay, so let's go ahead and do, basically a compute node booting is very similar. The difference being that you need to start a compute set. Let's see, do I have? Here we go. Here's a cluster where I haven't actually got the nodes booted. And so for this one, I can demonstrate how you kind of request a job to start a node. And so in this kind of scenario, you would ask that you want to start a node for a specific cluster, and you might say that you want to have one node boot, and it will find a node that it can run from, or that it can boot, and it will boot it. In this particular instance, this cluster is configured to run under multiple allocations. This is actually a feature we have with Comet Virtual Cluster, where a virtual cluster can run and spend money under multiple allocations. Basically, the backend detail is that if a separate Exceed allocation adds the virtual cluster account to their allocations, like you might do with a gateway, and then the cluster admin starts nodes for them, they can run their jobs through the virtual cluster on that node. In this particular case, I'll start it up in this fashion. And so what this is actually causing on the back end to happen is a job is getting submitted through Slurm to request compute nodes to be allocated for this particular virtual compute node. And when resources are available, the node will boot up and it'll start and it'll join in. And you can kind of see here that we've requested this job, it's running under this allocation, and the node is going to get allocated and booted onto this node. We'll come back to this one in a second, and I'll show you something else on a different node right now. So again, I believe I have some of these nodes already set up and running. So this is a compute node running in the VCT01 cluster. You can kind of see it's just like a basic regular node. One thing I wanted to demonstrate with this is that we have basic IB functionality set up. This is SRIOV virtual functions passed into these nodes. And so this machine has an IB interface. It is set up for IP over IV. It has an IP address assigned to this node, and it can do MPI or regular other traffic on here. Again, I have some demos here. I can show you that if we run OMB or OSU microbenchmarks on this node, I'm kind of skipping the build of all this software for brevity, but you can see we're getting near line speed bandwidth on the node, and we're getting very close to native latency physically on the node as well. I've done very little to tune this, and I don't have all the limits configured to not get some of these messages from MPI to show you this kind of thing. Another test I have on this node that I can kind of show you guys is we've got OpenFOAM installed in this node, and I already ran the analysis to generate the data. But this is kind of an interesting one I can show you. Currently, Mac OS has kind of broken the ability to to do exporting from these nodes, and so I have to cheat a little bit and just use the console on the node. So I'll just bring that up now. Call it console VC1 VCT. So Nancy, I can see my timer's run out, and I had it set pretty short, so you just let me know when my time is up.
Yeah, probably go into like 10:40 or so would be perfectly fine. Okay. If you run out of material earlier than that, I'm happy to jump in, but yeah.
Looking at the wrong cluster, is that right? So what you saw there was basically you can't mix resources together. So all of the compute nodes are uniquely identified in our backend database, but you can actually rename these nodes any name that you want. And so to keep them kind of separate, we actually have to associate them correctly with the proper cluster. And so what I tried to do is start up here a compute node that didn't belong to this machine. It actually belongs to this cluster. And so I'll do things right, and it should work. Normally for most virtual cluster admins, they would only have access to their own cluster in this kind of environment, but because I have admin access, I can access all the virtual clusters, and so I can make mistakes more easily than most other people. Okay, so on here, what I'll do is just bring up X environment. Here we go. And so
make that a little bigger.
That'll be tricky. I don't think so. This part, you'll see in a second, it'll be more graphical, and probably don't need to. So the point is here, I'm going to run Parafoam with the model that I created before, and kind of, you trust me, I generated this model. It's in the tutorial code that we did this. If you follow the tutorial with virtual clusters, you can do the exact same thing. But this is just ParaView installed into this virtual cluster and running across the nodes in MPI mode to generate this kind of trial model. And assuming Apple fixes their X11 server software, you could just do a direct display back to your system. Probably would work fine in Windows, but it doesn't work currently on an Apple machine, so I have to demo in the console here. Hopefully you guys can all see this. I don't know if you can or not, but ultimately the answer is that you can do the analysis on the virtual cluster. Typically providing interactive access might not be the best choice for these clusters because their public network is all shared through the front end. But I mean, of course, I mean, it does work. You could do it. You can allow users to forward in your cluster setup and get, you know, desktops back to their system if you wanted. Might not be the best performance and not really kind of what these are really designed for, but it should work. Okay, so what else did I want to show you? Oh, so here's that front end that we booted. Again, you saw this one boot from scratch, and you can kind of just use the node as if you want. You can log into it now via its other interfaces. Let's see, I have that one over here. Oops. Where is that? That's over here. Okay. Oh, there it is. Okay, that's over there. Okay, so one more machine that I'll show you, just to prove that we really can do what I said. Not that anyone would necessarily do this for HPC, but some people claim that they can do stuff better with Windows. Here's Windows running in Comet Virtual Cluster to get my things showing up here, but with like full access to the internet. Let's see, where should I go? Somewhere I went before. So I guess hello. There we go. So this Windows machine isn't activated, so that's okay. But you can see that we have access here, and this machine is running. It's kind of private network the same way that our other compute nodes are running. If you install into this Windows environment support for InfiniBand and MPI, you could be running MPI inside of here as well. So that's like the quick flash run through for kind of user tools in here. Let me just see if he's here. And so I'll kind of open it up for any questions. One thing I'll let you know is I have a couple more slides if you guys want to see or get an idea of how OSG kind of orchestrated their workflow onto Comet. And in fact, the OSG system admin is in the call right now, and so he might be able to answer any questions if you have any specific ones. But kind of open it up for some questions right now for the last few minutes.
Yeah, go ahead.
Oh, sorry. Trevor, I have a question regarding the VM. Now, I just want to kind of understand, if we want a VM just for like a gateway, then the way to do that is we have to get a VC and then install our own VM, or is Comet planning to have like VM specific support?
So I would call a general purpose VM not something that Comet would provide, but a virtual machine that's actually hosting a gateway or providing gateway hosting capability is something that Comet would provide. And you're actually touching on a point that's got a little bit of overlap between gateways and virtual clusters. It's possible that if you're just going to have a gateway that submits to batch environment, that could be a gateway running on a Comet virtual machine on our hosting nodes as a gateway and would submit to Comet's batch system or even any other Exceed resources batch system. It's also possible that what you really want to do is run a virtual cluster with a gateway, and we could provide that just as a virtual cluster. The front end node has public access, and it could be your gateway hosting node as well, and could submit either to Comet's batch system or directly into your own compute nodes that you had to build. The main thing that's different with those two scenarios is that the cluster build is a lot more complicated than just a gateway front end build. So if you don't have a requirement for a custom software stack that would be met by having your own cluster, then you're probably better off just doing a gateway request in your allocation request. And that could be hosted on Comet's gateway system. And it might make more sense if your data is here at SDSC, because we can kind of take care of some of the details about access to data locally without having you ship it over the network.
And so if we're looking at just the first scenario that you spoke about, so there is a sort of a, we don't have to go through the thing about the virtual cluster in order to get a VM is what you're saying, right?
That's correct. So that's a separate request. That's more requesting gateway support on Comet. So if you have an allocation and you want to host a gateway, or even if you don't have an allocation yet, you could do a startup allocation and talk about doing that. I'm not sure that there's like a checkbox or a tab yet, like there is for Comet Virtual Cluster when you do a startup allocation request for gateways per se. And maybe Nancy can talk about that more specifically. But you don't need a virtual cluster to run a gateway, a single gateway host on Comet. You just need to request a gateway host. And be careful about calling it just a VM, because we don't technically just host VMs that are just machines for doing nothing. It has to be a gateway request.
Okay, and then another question is the maximum compute node duration. I think in the demo you asked for 2 days, but what's the maximum that you can ask for?
So we'll work with that. So it's kind of, because we use our standard batch system to start these jobs, nominally everybody like lives under that rule. So it's a 2-day wall time limit for people unless they work with user services and work with us to kind of get exceptions to that. And we do have exceptions made for that for things like gateways or specific use cases. So we have the capability to change that value for you. It was just using the default wall time value for these jobs when I did spin up that one node. But yeah, so there's flexibility there. Of course, we don't for the compute nodes themselves, it's more the workflow should be thought of and planned to make use of resources kind of on demand. The idea of starting up a machine and running it for a year is not the use case for Comet. It's a shared resource. We don't want to have it just sitting there, because it's likely that if you're doing that, you're not using it all the time anyway. And if you are, then you can just spin it up and shut it down and spin it up and shut it down. That's kind of the model that OSG uses. They actually have software running outside of our system that looks at the number of compute nodes that they're running and tries to keep them running the number of nodes that they want to run at any given time. And so that capability is there. But I would say that really the workflow should be thought out to be more of an on-demand. Spin up the nodes when you need them and spin up only as many nodes as you need them, because for the compute nodes, unlike the gateway front end, which doesn't charge your allocation, the compute nodes charge your allocation to be on, whether you're sending work to them or not. And so you don't want to waste your allocation having the node sitting there idle.
Okay, thank you. And one more question back about doing the gateway on Comet. Is it also, I presume it'll be up 24/7, and does that charge against the allocation if you're just doing that scenario one again?
No, so gateways are kind of like the virtual cluster front end nodes. We don't run those hosts out of jobs, and so we don't build them specifically through that way. So again, this is probably a question more for Nancy. I don't know how gateways are kind of allocated and build out the resource utilization, but the node that you get for a gateway or for a virtual front end for a Comet virtual cluster are not billed while they're on. So like, let's say you get a startup allocation for 6 months, theoretically that node could be on for the whole 6 months and you're not billed for any of that time. But there's a limited resource. I kind of showed you the slide. We only have 8 of these nodes with, you know, so many cores and so much memory. When allocations go away, we'll turn off your node. We won't delete your image right away. You might come back with another allocation, but we'll have to work out some of those details.
Yeah, let's, we've got a question in chat here, and then I'm going to move on to the next speaker, me. So I'll keep going here. But so I think these are really good general questions that, that Mona's posed. And also this is a, you know, pretty complex topic to cover in a half hour, 40 minutes. So you've done a great job, Trevor, piquing everybody's interest, I think. And we'll have to see if we want to schedule something longer for folks who like couldn't get to the Exceed 16 tutorial. So the chat question is, how many users have availed themselves of this VC capability so far? How do they request access? I think that's pretty standard through the allocations process, and there's a checkbox saying that you need a VC. And how long does it take to give a user group access? Yeah.
So those are good questions as well. Right now we have the OSG virtual cluster running in our production environment and 2 other allocated Comet virtual cluster projects that are running in our development environment. I don't think we have any startup allocations in yet. Those theoretically could get spun up more quickly than a full allocation going through the full XRAC cycle. Probably from our perspective, it takes a little bit of time to work back and forth with the virtual cluster team and kind of define their requirements. We don't actually ask you to give us too much information when you make the request. And so what happens when you make the allocation request and check the box for Comet Virtual Cluster is that ends up landing on someone's desk over here, and then we call you effectively and kind of go back and forth and make sure that Comet Virtual Cluster is a good fit for you. Then there's some details. We have to actually get you shipped out like YubiKey tokens to get you access to the system and things like that. So, you know, best case scenario, you're looking at probably a few weeks from the allocation request landing to actually getting running on the machine. Depends a bit on mail. We've had YubiKeys lost in the past. But other than that, getting systems set up in the dev environment for sure is pretty quick. And we're working to move everyone from dev over into our production environment as quick as we can.
Yeah, great. Thanks very much, Trevor. On the ECSS Symposium page, there are links to all the speakers and their contact information. So if you have any more questions for Trevor, you could follow up with him offline. Also, if you have any questions for Fugang on Cloud Mesh, we didn't talk about that too much specifically, except the demo of how it's being used. But he can also be reached, and those URLs are all on the symposium page. So thanks very much, Trevor. That was excellent, really informative. Let's see, one more question. Yan, you might have to, maybe Trevor can address this one in chat while I'm speaking. Is that all right?
Yeah, I can do that.
Okay, super. So let me see, I can just start sharing. Yeah, great, okay. Okay, great. Can everybody see my screen?
Yes.
Great. Okay. So I'm Nancy Wilkins Deere. I'm one of the, you guys all know me because I run this symposium every month just about, but one of the co-leads of ECSS. And what I'm talking about today on the symposium is a new activity that I'm involved in that just started this past summer. It's called the Science Gateways Community Institute. So I'm going to talk a little bit about what that means, you know, hopefully from a service perspective for all of you, and also how it relates to and complements some of the things that Exceed's ECSS program has been doing. So I think everybody on this call, is pretty familiar with Science Gateways, but I always like to start with just a little bit of a definition of what they are to sort of get everybody on the same page. So basically a web-based interface for accessing all types of different things. In Exceed, we typically talk about access to compute resources, but there are a lot of other things that the gateways can do. And the Institute is a little bit about those other types of things. So why are they important? I mean, basically, the types of problems that we're tackling in science today are a lot more complex. The infrastructure that we use to answer those questions is also more complex. We all see stories about reproducibility in science, and kind of there's a role for Science Gateways to play there. There's also quite a role in workforce development and teaching and getting people up to speed more quickly, contributing as graduate students to research groups and all sorts of different things. So it's a good time to be talking about this. NSF thought so too. This is the notice of our award that came in August 1st. So there are 2 software institutes awarded through NSF's S2I2 program. One of them is the Science Gateways Community Institute. The other is the Molecular Science Software Institute, led by Daniel Crawford at Virginia Tech. So I think probably most people know this pretty well also, but gateways are in wide use in Exceed, and starting in about 2013, the number of people running jobs on Exceed resources via gateways exceeded those coming in via the command line and running jobs. So we're starting to see more and more. If we go to this listing, I probably won't jump out and do this right now, but there's a listing of all the active gateways that are using Exceed today, and those are, for the most part, publicly available for anybody to use. So you can go to the portal URL for a gateway and get your own account and run jobs and that sort of thing. So for folks on this call, you might know people who want to use existing gateways, things that are on that list. Or you might know people who want to develop their own gateways, and either way we can help with those things. So in Exceed's ECSS program, which I think most people are pretty familiar with, we can help in a number of different areas, from code optimization to large-scale visualization or data analytics, but we can also help integrate Exceed resources into the back end of an existing Science Gateway, and that's typically what we've been doing for the last 5 years. What we've tried to stay away from is doing front-end build from scratch development, and we also haven't been able to work on gateways that use resources that are not Exceed, just because of the mission and the funding and that sort of thing. So that's what we do today through ECSS. So where the Science Gateways Community Institute can kind of step in and expand on that is, now we can help with that front-end development. So now, through a combination of the Gateway Institute and ECSS, we can take you all the way through, an initial idea, build the gateway, incorporate Exceed use, or Exceed resources. But what we can also do is work with folks to develop gateways that don't use Exceed at all, that don't have anything to do with Exceed. Maybe you're running on campus resources, maybe you're using Amazon, or gateways that don't have anything to do with computing even. So there are gateways, to data collections and sensor streams, citizen science aspects to gateways. So it's just sort of greatly expanded. And I know I wanted to make this point kind of strongly, because with me being involved in both of those 2 programs, it's easy to kind of not distinguish between the 2, and they are kind of different. But I think complement each other nicely. So this is what we've proposed to do, and I'm going to go through each of these areas in like 1 or 2 slides and describe what they are, and then describe actions that you can take to be involved with any of these things. And so, what I didn't put in these slides is just sort of all the background leading up to why we chose these 5 areas. So there were years of focus group studies and large-scale surveys and that sort of thing. And it was basically through our involvement, starting from the TerraGrid Science Gateways program till now, and looking at what kind of challenges gateway developers faced. So we would see projects coming from all different types of domains. The only thing they had in common was that they were all using TerraGrid resources, they were all using Exceed resources, but their funding models and management structure and reasons for being and things were all sort of radically different. But in seeing all those different projects, you sort of got a feel for, this really isn't an easy thing to do. And is there anything that we could do to make it easier? Are there certain, services that gateway developers could use in common that would make their job easier? So that was kind of the thinking behind even proposing such a thing as this Gateways Community Institute. So the incubator, the basic realization here is that it takes a lot of different types of expertise to build a gateway, and I'll show this on an upcoming slide. But often if you're a small research team, you can't afford all those experts all the time in your project. So wouldn't it be nice if you had this sort of business incubator model where you can grab the expertise when you need it instead of hiring it in full time? So you're maybe talking to someone for a shorter period of time about, please do a usability analysis on my gateway, or can you do a cybersecurity checkup and make sure that there aren't any holes and that sort of thing. So the incubator program is going to give access to gateway developers to all these types of expertise, and it's pretty broad what we have. And today you can go to this link and request services. This is a lot of these things. If you go, sciencegateways.org is the main site for the Institute, and we've been running pretty fast since August 1st, getting all these services set up. So there's still a little ways to go in terms of documentation and filling out that website, but you can actually request services today. And so this is a graph of some of the data from the large scale survey, and it just shows some of the range, and this isn't even all the types of things, but the range of things that people wish they had or had on their projects, and it's pretty varied. And in the text box down there, you see some of the experts that are involved with the Gateways Institute. So the CTSC led out of Indiana, so experts on cybersecurity, experts on sustainability, especially for digital resources, experts on evaluation impact analysis, and also internal resource development, and that's kind of campus-based pods of gateway expertise, and I'll say a little bit more about that later. So there's a lot more than these 4 bullets. There's usability experts and software engineering experts and all sorts of different things. So we're hoping that that's going to help, having access to those types of folks for shorter periods of time. Extended developer support, Marlon Pierce leads this. He also leads the ECSS Gateways arm. And this aspect of the Institute is modeled a lot on what we've done in ECSS. That's been viewed as really successful. The PIs have been pretty happy with ECSS services, and so this is really similar. We'll get engaged for months to a year. The difference being that we can help develop a gateway, from the ground up, and kind of work with you on all the things you need to think about if you're going to be successful developing a gateway. So community building and keeping track of users and impact and publications and all the things that are going to kind of help you go to the next level in terms of the utility of the gateway and funding streams and all of that sort of thing. So extended developer support, this is the most similar to ECSS, except that, as I say, you can do front end work, and you can request this today. This was the easiest part of the Institute to spin up because it was so similar to existing programs. So Marlon's actually got a lot of projects in flight right now. I'll talk about those a little bit later, but these can be requested right now also. I should add that we're applying to become an Exceed Level 2 service provider. So probably within a few months, you'll also be able to request Institute services via the Exceed allocations process. But you can also do it independently as well, because as I said, we're trying to not just replicate, what's already been done in Exceed. So one of the other things we're doing is building a scientific software collaborative. So what this is a couple of things. One, it's a list of publicly available functioning gateways that anybody can use worldwide. It can be very difficult to find to find gateways in your field. You can't really just Google for them very well. A lot of people find them by word of mouth or publications, or sometimes kind of by accident. And so we think that there's a large service that we can provide for the wider gateway community by simply raising the visibility of things that are out there and that work and that are publicly available. So we want to do that. What this will also have would be software used to build gateways. And you can see some really interesting features of this repository maybe, where you could see working gateways. You can also learn what they were built with. You can also chat with the person who built them. So there are a lot of things that we might do here as far as developing community. This is still in development. There's not really an action to take to say, I'd like my gateway listed here. I'd like my software listed here. I'd like to work with the Gateways Institute in using my software to build gateways. Those are all going to be future opportunities. Right now, the best way to stay apprised is just to sign up the mailing list for the mailing list at the URL here, and we'll be keeping people up to date as we roll these things out, probably within the next 6 months or so. So this is kind of future and coming, but not quite an immediate action to take yet. But we're excited about what this is going to provide. Community engagement and exchange. So this is, you'd see if you look at that Software Institute call, a lot of it is about building community and kind of creating these communication channels between people who are doing similar work regardless of the discipline. And so that's a lot of what this community engagement and exchange is about. So if you have a really vibrant web page where you've got blogs on gateway development and successful gateways, you've got job postings. I'll say a little bit more about that later. You've got case studies, gateways in the news, webinars like this one. There'll be also a monthly gateway webinar series that will actually take the place. Marlon's been doing a series out of the ECSS Gateways program for some time in Exceed 1. We'll be working together to kind of combine that, I would say, with a monthly webinar series that comes out through the Institute, just because there's a lot of commonality. I don't think there's a need to do 2 separate webinars. So that's going to be spun up starting in January. Let's see. We do an annual conference also, which is kind of a nice scale. This is building off about 10 plus years of gateway workshops, and it's this award is allowing us to expand on that. So a couple of days instead of just a 1-day workshop, tutorials, posters, receptions, student support, travel support, that sort of thing. So keep an eye out for future gateway events. We did our first one in November. That was we wanted to stick with this fall time frame because of the previous history, but it was a bit of a scramble from October or August 1st funding start to early November conference. So we might not have gotten the word out quite as widely as we would have liked. But next year we'll be in Ann Arbor in the fall, and so that should be a nice event also. But there's a lot of opportunity to interact with other developers there. This bullet towards the bottom here, building gateway expertise on campuses. This is something that that we're really trying to promote. So most of the research gateways are built by staff members at campuses, and they're built most effectively if you have real stable career paths for gateway developers. If they're not sort of living from one grant to the other and not seeing this as as a real long-term career. The idea here is to build a group that has expertise at a campus with gateway development. And then when your research grants come in all across your campus, you have this pool of people that a PI can call on to become involved in their project. So it's more efficient for the PIs rather than putting out job postings every time you get a new award and that sort of thing. And it's also more efficient for the staff members to feel like they have this kind of continuity of projects. And we think by improving that working environment and working relationship, we're going to improve the quality of gateways as well. So this is going to be a real active area for us. We expect to be working closely with some of the campus champions as far as what this actually means on the ground and how to do such a thing. There's some examples of campuses that do this really well. There's some examples of places like my own institution that do this a lot less well. So we're excited about this kind of growing area. So kind of stay tuned for that. So really the action here is keep an eye on conference schedules if you're interested in such a thing. Contact us if you're interested in contributing content. Maybe you're a gateway developer or a gateway PI and you'd like to be interviewed for a blog or a case study or things like that. So there's a lot of ways to get involved in community engagement. This just shows sort of the global nature of this work. So as I mentioned, the US workshops have been going on since 2005. And there's been a series of European workshops that have spun up starting in 2009. Sandra Gessing at Notre Dame has been really involved in launching those. And the Australians have just started a series the year before last. So there's some really nice opportunities, one, to travel to really neat places. Sandra seems to pick always the greatest locations for the European series. Unfortunately, they're almost always during the Exceed review, so I can never go. But it's a really neat way to see how different countries and different organizations are handling similar programs. So there's a virtual lab aspect in Australia, there's virtual research environments in the EU, and there's really a lot of knowledge to be gained by interacting with these other groups. We have folks from the European series and the Australian series come here to ours, and a lot of the US folks go to theirs as well. And what we also do is we publish a special issue journal that combines submissions from all three of the workshops, and we do that once a year. And it's another way to kind of promote what gateways are doing, allow people to publish about something that might not be a good match for other types of journals, but still needs to be shared. So that's the international aspect. Workforce development. So you might imagine web development is really a natural fit for a lot of student activities. And so we're very much up on that. I think gateway development, it really straddles, it requires these sort of bridge people where you understand technology, but you also need to communicate with scientists about their needs, and creating something that both uses the right technology and meets those needs is a really special skill that I think is useful in the workplace in a lot of different aspects. So kind of training students to be gateway developers can also help them for all sorts of different career paths. So we're very much cognizant of that. So there's a lot of funds in this area for fellowships and internships for students, summer coding opportunities. Linda Hayden at Elizabeth City State leads this program. She started up this Young Professionals Network. Initially, we're also working with some underrepresented groups, both Novachet and ADME, who you see listed here. Also working with faculty to use gateways in the curricula. We're really seeing more and more gateways being used in this way. And if we can start advertising gateways that are used in this way and the materials that are used to teach, through that repository, I think that's going to be a nice step forward. career tracks, I talked about that a little bit. And here right now, the way to stay abreast is to really just sign up for the mailing list right now. So we had targeted travel support for the recent conference, but kind of getting the bigger picture and the bigger sense of what the opportunities for this program, this part of the program are, is something that's probably still developing over the next couple of months. So what are the summer opportunities going to be and that sort of thing. So that's workforce development, and I think these are some of the early folks these are, I think, most of the early folks who've expressed interest in the extended developer support. And you'll see that not all of the folks on this list are people that we can work with. So the word really has gotten out pretty widely. If you see at the bottom, we've got an entry from Egypt that we probably won't be able to help. We have the same USPI restrictions that the exceed allocation process has. But just the fact that someone from that far away has heard of the project and the call and found their way to the application process, I thought was pretty interesting. I think the other interesting thing here too is the variety. So you've got some gateways that have this really high level of compute. So like astrophysics, you see Mike Norman, Michael Cianfranco, and Cryo-EM is also kind of it's going to be a heavy compute kind of gateway. But then you also see citizen science. We have a couple of campus champions who have requested support. So Doug Genuine and Jack Smith, I believe, are both campus champions. And Drew Lamar, I believe he was at the conference here in the fall, and just sort of an interesting story. Sometimes people look at developing gateways as something that isn't really going to contribute to the academic reward structure and tenure track and that sort of thing. My understanding is that Drew actually had the opposite experience, where his involvement in the gateway sort of accelerated that kind of path. So we're starting to see things change as far as what gateways can do for academics too. And it looks like I am right at the end, and that's my last slide. I haven't been able to, let me escape out of here and see the chat window and see if you guys have any questions before we break up.
Nancy, this is Ralph. Can I ask a question?
Yeah, you sure can.
So when you were talking, especially about the incubator, you talked about things like asking you, a gateway can come to you and say, well, can you do a usability study for us? Or can you evaluate whether our security efforts are good enough, or something like that? What I'm wondering about is what sort of involvement from the PIs in those efforts do you require? Because it sounds like you were willing to have people throw stuff over the fence to you, and we know that's not a sustainable situation.
Yeah, that's right. And I think in extended developer support, where we're committing a lot of resources for a long time, that's where you really want that buy-in, like we see in ECSS, where if you throw something over the fence and somebody does a whole lot of work without involving the research team, there's a good chance that all that whole lot of work is not going to get incorporated in a production build and that sort of thing. So that we would really need it. For a usability analysis, you might be able to have an independent group, poke around for a little bit and do a standard analysis that they would do, and then get back to the PI. So I think because it's a little bit less effort, and because you sort of want somebody who's standing back with a more independent viewpoint, I think for the consulting part of that, that separation might work better than it does in ECSS. Okay. We'll see how we go on some of these things.
Okay.
Any other questions? I would love it if my little Zoom window here would come back, so I could.
So Nancy, this is Yan. I have a question about the role of the second component, the scientific software collaborative component. I feel it overlaps with the extended developer support and the community engagement and exchange. I wonder first if there's any software architecting effort in this component, because its purpose is to reuse existing or best practices. And what's the difference from
Yeah,
the other?
the best way to think about the collaborative is as a repository. So it's a place that you can find things. It doesn't include anybody who can help you with the gateway. So that's the difference between extended developer support. And it's not really doing any kind of outreach in the way of organizing conferences and, you know, having active web pages and things like that. It's a repository where you can find things, both software to build gateways and gateways themselves. Does that make sense?
Yes.
Not exactly.
Yes, it makes sense. We need to have a repository first to look at, but then what? That's
right. So it could be that you find a working gateway that does everything you need, and therefore, you know, you don't need to build one after all. So that's one way that the collaborative might play a role. Maybe you find software there that's interesting to you to use to build a gateway, or you see an example that, hey, this I really like the way this gateway looks and its functionality, but I need it to do something different for my own purposes. And so that's where we could help work with you to build that. So you're sort of getting visibility into products, I would say, through the collaborative, and then people support elsewhere.
Thank you.
And Nancy, sure. There's a chat question.
Oh yeah, could you relay it, since for some reason Zoom has completely gone away here for me.
The question is, how specific does one have to understand a project before asking for support?
That's a good question. I mean, a little, it's, you know, the more details you can provide, the better. I mean, I think that's sort of part of the whole gateway process, is kind of having that clear vision about what you want to accomplish by way of the gateway. But you know, at the same time, if you just want to talk to somebody and say, "Hey, I've got these vague ideas. Do you really think this is a gateway or not?" You know, we're happy to have that back and forth conversation even before somebody puts in an application, because I expect, you know, once you back up to the level where you're helping people start from scratch, you're going to have a lot of these not fully formed ideas, and I think that's okay. That's, you know, we want to encourage that. Great. Okay. Looks like it. We are 10 minutes over time, so why don't I let folks leave who want to leave, and I will sit and I'll answer some of these chat questions in chat, or I'll just stay on the line here for another 5 minutes or so. But everyone can be free to go. Sorry, I thought I would be a little quicker. But I want to thank Trevor and Fu Gang for assembling materials and presenting on this month's symposium also.